At our area measurement of a square. Determine the area of each square. 3 centimeters is the length of one side. What does that mean the other three sides are? 3 as well. So then to find the area of it, what do we do?
3 times
3 times 3. How do we find the area of any four-sided figure?
Length times width.
Length times width. So if it's a square or a rectangle, area is equal to length times width. Okay, so the first one's 9. The second one then is 25. Then we have to decide the side length. Okay, so this one sometimes, so if we're talking the area of a square, we can go side squared, right?
Yeah.
So if I'm given the area of it, how do I find out what the length of one side is?
So area
Ellie?
is
Square root of the area.
That's right. That's right. So we take the square root, cancels that with that, and the square root of 81 is 9. So we've got that. How about M? Square root of 36 is 6. Good enough. So some of the other areas. Triangle. 1/2 base times the height. Area of the circle. Pi r squared. And that basically sums up all of that page. All right, flip it over then. Area of a parallelogram. Okay. So, a parallelogram. 2 sides are parallel to each other. Close. Let's make that. Opposite sides are parallel to each other, but they don't form a right angle. So basically what we're looking at in this case is, if it's not a square, this would be considered a parallelogram. Or, sorry, if it's not a rectangle, this would be considered a parallelogram. A rectangle would be different length and different width, slanted, so the sides are still parallel to each other. If it's a square, you guys know what a four-sided, in which all 4 sides are the same and it's on a slant, do you know what that shape is called? Rhombus. Very good. Awesome. Okay, so a parallelogram. There's 2 ways in which we can do this. We can find the area by taking base 1 plus base 2 divided by 2 times the height. Now that's the area of a parallelogram, or a trapezoid. But in a parallelogram, if you just think about this for a second, because these are parallel, if I cut this off right here and then attached it over here, what shape have I just created?
A rectangle.
Correct, a rectangle, right? So to find the area of the rectangle then, I've got one measure is 12 centimeters, the other one is 4 centimeters, so what is the area of that rectangle? 48 centimeters squared. That's great. Okay? Or in this case centimeters, they have meters squared there. All right, to find the area of a triangle, 1/2, 11 times 5. So 11 times 5 is?
55.
55. What's half of 55?
27.5.
27.5 centimeters squared is the area of that. That's right. Area of rectangle O, 8 centimeters by 5 centimeters, 40 centimeters squared. And then the area of circle Q is pi times 10 squared. Give me an approximation.
330.
Well done, Harley. 314. Punch that into your calculator using your pi button.
0.16.
Whoops, huh? 110 squared. Great, what did you say it was? 314.16.
16.
Good enough. Awesome, thanks. Centimeter squared. Good job, gang. Flying through this again today. All right. Now, what surface area of 3D objects? Okay, let's start with this here. If I had a square, and let's say that square measured, or sorry, a cube, not a square, but a cube. Not very well drawn, I drew the depth too far, but anyway, so this is 6 by 6. Okay, so how do I find the surface area of that?
Well, like, since it's a square, all the sides would be the same. So, like, if you know that there's like 6 sides
Mhm.
on it, you could just times like 6 by 6, which is 36, and then times that by 6.
That's right. These are poor number. I'm gonna switch this. I'll make this 5 by 5 by 5. Okay, so surface area. That's what we call the areas on the faces. So the area of one face is 5 times 5, right? 25. And how many of those faces do I have?
6.
6. So I would multiply that by 6. Good enough?
Yeah.
Okay. So what is that?
That
25
would
times
be
6, 150, sound right?
Yeah.
Okay, so what if I did this though? Okay, I want to find the surface area of this guy.
Length times width times height times height.
That's fine.
Fine, yeah?
Oh, yeah.
Alright,
So,
so if I remember correctly from last year, so on this, there's two of the same on every side.
That's right.
So there's two surface, or there's two sides that have an area of 8 times 10, so 80.
Okay,
8 by 8.
so let's do that. So 2 times 8 times 10 plus, so that's the area of the front face and
The back face.
the back face. So that would be the back and the front face. Good. Plus
8
times 4.
2 times 8 times 4 plus
10 times 4.
10 times 4, right. So all of that would give you my surface area of that. That's right. Is everybody following what we're doing here?
Wait,
Okay.
so like you're timesing 8 by 10 up there?
All right. Yeah. Okay, let me show you a different way of doing this. Now, if you were to take the essentials route and you did the, which is essentially this, so maybe we're going to get into it. But I would take this thing apart. Okay? So there's 6 faces to this, right? But there's 2 that are the same for the top and the bottom are the same. The sides are the same, and the front and the back are the same. We all agree? So one way you could do this question, if you can't figure it out the way it looks, is draw it out like this. Well, I have 8 by 10 here, times 2, right? The top would be 10 by 4, times 2, right? So that's the top and the bottom. I got the front and the back, and then the sides would be
4 times 8.
4 times 8, and there'd be 2 of those. Okay? So if you have a hard time visualizing it on here, break it into what we call its constituent parts, and then multiply it out that way.
wait, but why would like the sides be different than the other sides? Like the front and the back.
Because the front is 10 this way, right?
Yeah.
By 8 this way. So that's my front and my back. Agreed? The side is right here. So how deep is it? It's 4.
Okay, there we go, yeah.
Is that better?
Yeah.
Okay?
So just break it up like that.
Yeah, that's the easiest way to do that. You okay? Awesome.
I got one last quick question. Could you do like 8 times 4 or oh, no, I figured it out.
You okay?
Yep.
All right. Okay. The next shape then is this guy. So great. So a cylinder. Okay. So I want the surface area of it. The entire surface area. I'll explain that in a second. Okay. What shape is the top and the bottom?
Circle.
Circle. And so I have a top and a bottom, so I go 2 times pi, right? Times
R squared.
r squared. So depending on what my radius was from here to here. Okay? That's the height. So far so good? Okay. How do I find what we would refer to as the lateral area, which is basically, the way I like to put it is, if you peel the label off the soup can, how do I find the area of the label?
Length times
Okay, now that's what I would think too, right? Length times width. That'd make the most amount of sense. Okay? But it theoretically, when we pull it off, it works out to be a rectangle, right? But what shape is it actually in when you've got it going around?
Cylinder.
A cylinder. So what I want to actually find is the distance around that cylinder, Harley.
Yeah,
You have to find the circumference
of the
one of
circle.
the circles and get the length.
That's right.
And then times it by 6.
So how do I find circumference again?
Pi times r squared or pi times.
Pi times R2,
By
R
diagonal.
double, or
Actually,
R2.
actually.
Okay, so not r squared, times 2. So 2 pi r or pi d. I like 2 pi r. Again, it's a math thing. I like 2 pi r because we use it in grade 12 pre-calculus and grade 11 pre-calculus. So we use 2 pi r. And the height is h. Okay? So,
The height.
if we look at this, then it gives us one as 5 centimeters is my radius, and my height is 6 centimeters. Okay? So the area of the two circular ends would be 2 pi 5 squared plus 2 pi,
R squared.
not r squared,
5.
my radius, which is 5, and my height, which is
6.
6. Okay, so punch that into your calculators.
Wait, I have a question. Why is it r squared? I just don't understand. 2 pi r squared.
I am looking for the area of this circle right here on top.
Oh, the area. Okay, yeah, I get it now.
Okay.
The area. Yeah.
I got it. Oh, do you want me to add them up for both?
I want this plus that. So I want your total.
I don't know if I did it right, but I got 697.43.
I got a third of that, basically.
I think sounds wrong.
Okay.
I don't know how
Oh yeah, probably.
All right, here's what we're going to do. I'm going to show you your keystrokes then. If we're struggling, I'll show you keystrokes. So clear your faces on your calculator so you got nothing on there. And then we go 2 times. Find your pi button. Some of you will have to second function or inverse it to get your pi. And then we're going to times. So you can go 5.
Times 5.
about 219.
But no, you
Now
have to bracket it.
you can do x squared. Okay, find your x squared button on there. Everybody found that?
I didn't do that.
Everybody found their x squared button? Okay. The other thing you can do, because you've got good math skills, is you could,
Just do it in your head.
what is 5 squared?
25.
So you could put 25 there if you wanted instead. Now, we're going to add 2 times pi again, times 5, times 6, and then hit equals. Okay, so let's do that again.
I got the same answer I got before.
Oh, 345.57.
5, 8.
Yeah, you need to round up, Kalen.
340,
5, 5, 8.
thank you.
345.57 I got.
That you got.
Round it up.
I never.
No, but it got 345.569 and then I rounded it up. So I got 7. Pretty close. I don't know
Yeah,
what.
5 sevens, right? I don't know what.
Yes, 5.7.
Wait, but how come when I
know.
do, how
Okay.
come when I do a number times, like a number times pi, I don't have to put times and it works?
Because the calculator, because this is a character, the calculator assumes that there's no other sign there, It's the same as, why do you, if I put this, okay, let me do it like this, sorry.
Yeah, like,
2 pi, it knows to take 2 times pi,
yeah,
okay? That's what it means. So if I was to put a letter here, 2a, I know that it's 2 times a. I don't need a multiplication sign, and neither does your calculator when you put the pi in there. So if you don't put the pi, if you don't put any sign in there, and you put a pi button in there, it will always multiply it. Okay? We okay so far?
Yeah.
Yeah? You guys done some of this before?
Yeah.
Okay, great. Okay. We'll do it just for fun, but I don't like doing estimates, but we'll do it anyways. Go to page 92. All right. Think of other objects similar in size and shape to the following: a compact disc. What's the same as this? What's something that's similar in size to a CD?
Donut.
Sure, donut works. Great.
Where is this?
92.
At the top.
A cell phone?
calculator.
Calculator, sure, perfect. Justine is the manager at a community center. She needs to estimate how much floor area she needs to be cleared to make space for table tennis. As a referent, she uses a floor tile, which is about 1 foot by 1 foot or 1 square foot. Measure an area of 1 square foot and compare it to the top of your desk. Estimate the area of the top of your desk. All right. These squares on the floor here, they would probably be, I would say, a 1/2 foot by a 1/2 foot. Okay, so if you made 4 of them, that'd be a foot by a foot.
Yeah.
Agreed? No, good, let me make sure of that. I think they're both 6 inches would be my guess. Okay, they're actually 3/4 of a foot. So that's not gonna help, but for our purposes. So if this was, if the square on the floor was 1/2 foot by 1/2 foot, approximately, look at the top of your desk. What do you think the measurement of your desk would be? So compare it to the bottom, compare it to the tiles on the floor.
I'm just gonna say 2 feet.
2 foot by
One.
1.5.
Sure,
2 foot
Write it
by
down.
1.5.
2 feet by 1.5. Not terrible. Not a terrible guess.
About 3 square feet.
I don't think so. You think so? What'd you put down? 2 by what?
1.5.
Okay. So you think it's gonna be 3 square feet?
Well, I did 2 times 1.5.
Sure, you did it right. Okay. Justine estimates that an area of about 200 floor tiles is needed to play table tennis. A large number like 200 floor tiles takes time to count. Think of a larger reference. Bless you, with an area of about 1 yard by 1 yard, count 1 square yard, which should be quicker to point out. All right, never mind. We're not going to do that. Let's look at example 1. This part of a ruler has an area about 1 square inch. What other reference can you think of for areas that are 1 square inch by 1 square inch? Go ahead.
Like objects?
Yeah.
Oh,
Something that's 1 inch by 1 inch.
A little wooden block cube that.
a dice.
That's a
No,
centimeter.
Dice would be like a centimeter.
Take your thumb and put it over the picture. Is that close to 1 inch by 1 inch? Some of you? Yeah? Might be a thumb, might be 1, right? Okay, so you need something that's this size. What else is that size? Anything you can think of? Nada? Okay, what about 1 square foot?
One of the tiles in the old school.
Sure.
Tile.
Tile on the floor, my word. Okay, all right, so that whole first section, 4.1, is estimation, which is the same as 4.2, which is page 94. The difference being you're actually going to use grid paper and estimate based on the size of the grid given to you. So whether, like a normal graph paper is a 1/4 inch by a 1/4 inch. All right, so that may be what they're going to give you as your sizes. All right, what I need from you today, we've only got a half hour left because of that. Page 90 and 91 needs to be completed, 93. And if you're done that, you can start in on 95.
90, 91.
90, 91? 93, and you could start in on 95 if necessary. All right?
Okay.
Okay.
Mr. Newton and Armin. So I actually did most of these on Friday.
Okay.
What if the, give me an approximate, 5 times 40 is,
Can you do that in your head? 5 times 4.
20,
Right.
so then 5 times